Okay, first we will review our first exercise, exercise 1 regarding the watershed boundaries. I'm sure it will not be in the exam because, yeah, you already did in the class, but you should, maybe you want to know the correct answer or how to do it correctly, but I'm pretty sure you already do it mostly correct. And regarding this watershed boundaries, all of you has different watershed maps. So you will make different boundaries also. There is this one outlet. So if you have like one outlet, you should draw the watershed boundaries based on the outlet, because the boundaries means the water is running going into the same outlet or same point. But if there is two outlets here, for example here and here, there will be two watershed boundaries. So this is the I make it like a quick draw before class, and it's not that perfect, but you can see from here we got the small river around this big our main river. You have to like distinguish between those rivers, whether the river is going to the same point or not. Here we have the river with the color of blue, is the river outside our watershed. And then we have the river with the lilac color or lavender or purple, pale purple color. This is the one that our watershed come from. And then this is the boundaries. When you draw the boundaries, you have to pay attention to the contour. So it should be following the contour more or less, because when you draw with pen, it's a little bit hard if you use mouse to follow the contour perfectly. But the right one is the boundary should following the contour. And regarding the second exercise, we have the Thiessen method exercise. For these Thiessen methods, most of you are answering the calculation correctly, but a lot of you didn't draw the Thiessen polygon correctly. Yeah. So here we have the data of the rainfall height at each rainfall station. We have 5 rainfall stations, and then from each rainfall height, we have to calculate the weighting factor of each rainfall station times the rainfall height of each station on each date. To know the weighting factors, TW, we have to calculate the area of each rainfall station. This is the example of our watershed maps. And then if you got the watershed map looking like this, first you have to connecting the nearest station to the nearest one. So this station A connecting to the B connecting to the E, and then E connecting to the C connecting to the D connecting to the A, and the other one here we have D connecting to the station D. 1, 2, 3, 4, 5, 6. You don't need to connect the B station to the C station. As you already see, this is quite a big distance over here. And then you don't have to connect the D station with the E station, because it's also quite big. And then after you connect all of the stations, So if you have like 5 stations, you have to make more than 5 line connection. Here we have the area divided for the area A, B. So after this, we decide which one is the average point or the middle point of each line, and from A to B, which one is the middle point, A to D, which one is the middle point, B to E, of course, the middle point is in this, is here, D to C, it's a little bit here in the half, and then E to C. After we got the middle point, we draw the line from those points until this line is meeting with another line from the other middle points. For example, here we have the line from AB meeting with the line from AD. And then here we have the line of BD. The middle line of BD here, we have to draw it along so that the line from BE can meet with this line. And then we have the other line from EC here, and then we have the other line from DC here. After we got the all of the line connected, and here we can calculate the area of each station. But before you calculate the area of each station, you have to calculate the total area first. Because if you don't calculate the total area, there is possibility that there is an area that you didn't cover. So if you calculate the total area and then you calculate each area of each station, and then you sum it into the total area, and then the total area is not the same with the total area that you calculate earlier, there might be an error in your area. Maybe there is an area that you didn't cover yet, or if the amount is bigger, maybe there is an area that you don't have to cover, but you cover it. That's why it's doubling. So it's better if you calculate the total area first. Here we have the total area of 168, and then you calculate each area, and then you sum it again. Is it correct, 168 or not? And then after that, we can calculate the weighting factor, DW, based on the ratio of each area with the total area. And then after that, we multiply the weighting factor with the rainfall height. And after we multiply it, we total it with the other amount from other stations. And then here we have the average of rainfall. After we got the average of rainfall on each date, we can see the maximum of the average rainfall, R max, is this big, 101.582. This is this happened on the date of 2nd January in 2004. So yeah, most of you calculate this table correctly, but mostly didn't draw this watershed map properly. But it's okay because it's part of the learning process. It's part of the exercise. So if you have like if your score on the exam is not that good, the score from the exercise can help it, and vice versa. If you exercise not so good, but your exam is good, so it can also help it. And then the third one, the newest exercise. This is the exercise that we did since last week, right? I gave this exercise last Thursday, and then you have to submit it this Thursday before class. And now we will begin to review it. Actually, I have good feeling about this because there's no student that asked me regarding this exercise. Means that you already understand how to do it. There's no confusion on you in doing this exercise today, I guess. I hope so. So I haven't checked your answer yet, but I'm pretty sure that you did it great. Wait. Okay, so the third exercise regarding the infiltration mixed with hydrograph. So actually this hydrograph, I'm pretty sure it will be coming out on the exam because the materials for the exam is until hydrograph. So I don't know whether it's trapezoidal or triangular hydrograph, but it's hydrograph. So here we have the infiltration and hydrograph materials. We have 4 rainfall station A, B, C, and D, which are located in a watershed with an area of 50 kilometers square. And it recorded the rainfall data that occurred for 4 consecutive hours as follows. Here we have the first hour, second hour, third hour, and fourth hour of the rainfall. And here we have the data from each station of station A, B, C, and D. This rainfall causing flood in the river, where the flood hydrograph caused by effective rainfall was triangular. So the hydrograph will be triangular hydrograph with a peak discharge of 30 meter cube per second, QP, and time base of 25 hours, which means the water flowing because of the rain since the beginning until the end. The water needs 25 hours to drain out 100% from the surface. So after 25 hours, there's no water left from the rain. And then here we have the question. Okay, first question, calculate the average rainfall for each hour of rain events using the method that you know. So for the average rainfall, there are a lot of methods that we already talked about earlier, previously on our, I don't know which meetings that maybe last month. And here we have the average rainfall using arithmetic method, which means we only average it based on the number of the station. So for calculating average rainfall, there are a lot of methods. For example, previously we talked about Thiessen methods. It's also for calculating the average rainfall. And then here we have the arithmetic method based on the amount, the number of the stations. So if we have like 4 stations, we have to averaging it by sum it and then divided it with 4. That's why here we have 8 for the first hour, and then for second hour we have 10, third hour we have 23, and the fourth hour we have 5 millimeters of the average rainfall. And then from the results of the answer from question 1, calculate the rainfall intensity for each hour of rain events and draw the hiatograph. So for the rainfall intensity for each hour, here we are lucky because the time is all the same. It's all 1 hour. But if this, for example, here 0 until 1, and then the second one, if the second one is 1 until, for example, 1.5, so the time span is only half an hour. So the intensity will not be this big. So because the intensity is the amount of the rainfall divided by the time. Here we have millimeter per hour because the time that we spend here is 1 hour. So 8 divided by 1 is equal to 8. But if here we have 1 until 1.5, so we only have like half an hour. So to average, to calculate the intensity, we have to divide it this average with the 1 hour. So here we have only half an hour. If the 10 millimeter is happening in half an hour, so for 1 hour, we will have like 20 millimeter per hour. And then here we have 2 until 3. So here, because the time span is each time step is 1 hour, so the intensity will be the same with the rainfall average. And then we draw the hiatograph. So hiatograph is different with hydrograph. So for hiatograph, the curve is related to the intensity of the rainfall. So the y-axis will be the intensity, the x-axis will be the time. For hydrograph, the y-axis will not be intensity, it will be the discharge. So that's the difference. Here we have the first hour, second hour, third hour, and fourth hour of rainfall intensity that we already calculated before. And then the third one, the third question is calculate the DRH volume. DRH is the direct runoff hydrograph volume, which means we have to draw the hydrograph first to know the volume of the hydrograph curve. To draw the hydrograph, we have to see the information from the problem. The problem said that we have the triangular hydrograph, but sometimes the problem didn't state it clearly. If the problem didn't state it clearly, you have to see the TC and TD here, the time concentration and the time base. If the time concentration is known, but there is no time of the rainfall known, which it means that the time of the rainfall is the same with the time of the concentration. So it can be said that the hydrograph is triangular. But here in the problem, it already stated that the hydrograph is triangular, so we don't have to think about it complicatedly. Here we have the peak discharge, 30 meter cube per second. And then we have the time of concentration, 12.5 hours, because we have the time base of 25 hours. So if the time base is known and then the hydrograph is triangular, it must be the time concentration is half of the time base. So here we have the shape of hydrograph, shape of triangular hydrograph. And then we have to calculate the volume by using the equation of the area of this triangle. And then we can calculate it using half times peak discharge time base. And then we have 1,350,000 meter cube of the volume of direct rainfall hydrograph. And after that, the fourth question is we have to calculate the effective rainfall. So for the effective rainfall, if the DRH is already known, you only have to calculate it by dividing it with the area. So we have the area of 50 something. The something is based on your number, like the last digit of your student number. Here is an example of 50 kilometer square area. So the last digit is 0. And then we have the effective rainfall of 0.027 meters or 27 millimeters rainfall height. And then based on the answer to question 2 and 4, calculate the V index. So the V index can be drawn in the heatograph as a line. Here we have the V index. V index is the line that divided the heatograph, whether it will be surface runoff or it will be infiltrates to the soil. So the upper part is the surface runoff, which means it is related to the effective rainfall. While in the bottom or below the V index line, is the one that have to infiltrate the ground and then going to be groundwater or going to recharge the groundwater. So the upper side is the discharge, the bottom side is the discharge. So this is, this is the discharge, the bottom is the recharge. And to calculate it, V index, we have to know the effective rainfall first. And here we have the amount of the number of the average rainfall intensity. Here 8, 10, 23, and 5 based on the one in the heatograph. So here we have 27 equals to 8 minus P times 1 because of the time of the duration. 10 minus P times 1, 23 minus P times 1, and 5 minus P times 1. Why it's minus P? Because the one that we want to look for based on the effective rainfall is the upper side, because the amount of this upper side should be equal to the effective rainfall because it's the surface runoff. While in the bottom side is the water that is coming into the ground, going into the ground to become infiltrates with the ground and become soil moisture. And using this equation, we can know the V index is equal to 4.75 millimeters per hour, which means the line will be right here. 4.75 is below 5. And after that, the question number 6, calculate the runoff coefficient alpha. For to calculate the runoff coefficient alpha, we have to look for the ratio between the effective rainfall and the total rainfall. For the effective rainfall, we already calculated it on previous problem, like 27 millimeters. And for the total rainfall, we have to sum it from the total of the average rainfall. Here, from this table, here we have the average of the rainfall data, and then we have to sum it to become the total of the rainfall. Oops. So we got the runoff coefficient alpha equal to 0.587, which means the amount of the water which is going on the surface or becoming the surface runoff is 58.7% from all of the water going from the rain. So from the total rainfall, 58.7% is going to the surface runoff, and the rest will go to the infiltrates to the soil. Yeah, so that's all for the review of the exercises that we already did until now. Should you have any question, please feel free to ask.
I think I have a question for the Thiessen method.
Yes.
Miss, what if the stations are outside the watershed?
Yeah, it's the same.
Because
The
oh, it's the
principle, the principle is the same. The principle is if the station is outside, but for example, the station C is outside here in the line number 18, for example. It doesn't make any big difference because it's still considered near to the other station. But if the station is on the outside of the watershed, but it's far, for example, here we have the station C on the bottom, on the corner bottom of the picture, for example, on the line number 20. So we should not consider that station as our station to calculate the Thiessen method. Maybe I can give you an example from our previous exercise. I will look for the watershed map with station outside the watershed, because the principle of the watershed map, the station can still be considered representing the watershed if the station is near to the watershed. It's not always inside the watershed, because on the on reality, if you calculate the Thiessen method using the real station, sometimes there is watershed with no rainfall station. What happens if there is no rainfall station in that watershed? We still can calculate the rainfall on that watershed by using the station outside the watershed, which is near to the watershed. So that's not the problem if whether the station is inside or outside the watershed. The main thing is whether is the station near or far to the watershed. So for example, let me see. Okay. Let's see. Okay, so for example, this one right here. Here we have two stations, which is outside the watershed. And you have to see the distance between this watershed to the station, the rainfall station. Is it considered close or not? So if you want to calculate the average of the rainfall, you have to consider this station A and station C, even though it's far from your watershed. Sorry, even though it's outside your watershed, because here we have the border of the watershed. So for example, here we have the border of the watershed. You have to see the area here. This area right here near this border of the watershed should be better presented by this station than this station or this station. So if you only consider the 3 stations here, yeah, it's okay. But for this area right here, it will not be good. It will not be representable, because for this area here, it's nearer to this station here, rainfall station here. So it's better representing with this station. Same goes with this with station C right here. It's okay if you only want to do using this for station, but in this exercise you cannot choose, I guess, because this is an exercise. But if in the reality, if you only got the data, for example, you only have the data for the this for a station, yeah, it's okay because you only got data for those stations. But if you have complete data for these 5 stations, it's better to use more station than the less station, as long as the station is near to the watershed, because you can see here from this border which one is nearer. This station looks nearer than this station and this station. So this station will be better representing area below here. Yeah, I hope that can make yourself more clear about this water exercise. So it same goes to the I have other, yeah, for this example also. Is it the same or no, it's not the same. For this example, it's very clear that this C and E station is near to this to the area of the watershed in the right side here. So for area right here, it's nearer to this C and E than to the B and D, which is inside the watershed. So if you want to draw it properly, maybe, oops. So you have to like connect this one, and this one, and this one, oops, and this one. After that, you have to make the middle line here, middle line here, then middle line here, and then here you have for this one, here you have for this one, and then it will meet here, then it will be right here. So this is for the A, this is for the B, this is for the C, this is for the E, this is for the D. How about if you only use the three station? Yeah, you still can calculate it, but you will use this like if you only use, for example, B, A, and D, you will get this this big for the B, and this one is for the D. But in reality, the area right here is nearer to this station, so it's better representing with this station than the number from this station for the area on the right side. So yeah, if you use it in reality, if you got the data, it's quite difficult to get the data complete for many stations. So if you got all of the data for this 5 stations, it's better to use the 5 stations. But if you only got the data for A, B, and D station, yeah, you can still use it, but it will not be that accurate on the side of this area on the watershed because it's nearer to the other station of the rainfall. Any more feedbacks from the one that asked this question?
That's enough, Miss. Thank you.
Okay, other questions? No, you will not draw Thiessen again on the exam, I promise. But maybe for Thiessen calculation, who knows? But for drawing, I guess not, because we already did it on the exercise. As long as you know how to do it correctly, you're safe. Because some of the students, as you know, if you want to do your, it's still far, but if you want to do your final project or your thesis in the topic of hydrology, you have to do this Thiessen method for calculating your rainfall, because this is the most approachable method rather than using the arithmetic method, which is only averaging all of the rainfall. It will be more not accurate than using this rainfall. So using this Thiessen method. So the Thiessen method is quite accurate than the arithmetic method. So usually students that take the thesis on the hydrology topics use this method, and it's not sometimes they are also not quite understand clearly about this polygon Thiessen, because maybe this topic is teach on the earlier semester. For example, here we have on 4th semester, and then you will cut your you will do your thesis on like 7th or 8th semester. Maybe you already forget, or maybe on the first time you study it, you already didn't do it properly. So it will be a problem if you use it in the future, if you do your final project in hydrology topics and then didn't use this method correctly. So yeah, is there any more question? Oh, I recorded the question and answer section. Okay, you cannot ask question when on the day on the exam. So this is the last chance. Yeah, you still can ask questions regarding the problems, the questions on the exam. For the last semester, is your exam in English or in Indonesian?
In English.
In English. Oh, okay. Yeah, so if there's no more question, I guess we can finish. It's 3:30. Yeah, I think I will finish this class now, and we will meet again on Thursday. There's no class in Tuesday, just in case you have exam on Tuesday. So for Tuesday, you can study by yourself using all of the materials that you already got, and I already uploaded the lecture from previous session. And then for the materials, it's already complete on the MyITS classroom. So I hope you can use it properly. And yeah, I think that's all from me. Thank you very much for your attention and participation. Sorry if I have like saying something wrong or lack of something. We are all still learning. We still learning, and then we learn together to be better in the future. So yeah, thank you very much, and have a nice afternoon. See you on Thursday. Bye bye.
Thank
Bye.
you.
Thank you, ma'am.
Thank you,
You're
Miss.
welcome.
Terima kasih, ma'am.
Have a good day.
Have a good day.
You too.
Hmm.